All right. Okay, so you can do a little example, and I just sort of, I can just show you this. Because we talked about the example before with the 2 and 3, just to show you that mathematically you could go through it. So if we have that every movie has 3 tropes, and where's the next one? And every, where have I written it? Oh yeah, and then we'll leave this one to be arbitrary. Okay, fair enough, yeah. The example, I guess, was where this was 2. This is a Kronecker delta of 2. Leave it to be arbitrary. So you could go through and do all these sorts of calculations. I know I've got... you get a lot of simplicity with these things because with Kronecker deltas, right? Because the generating function is just a simple piece. It's just x cubed here. Take the derivative of that, 3x squared, divided by that evaluated at 1. So the 3's cancel. You get x squared, which makes sense, right? So this is every node you choose has 3 friends, and every node that you hit on an edge has 2 other friends.
Average K, so going the other direction?
Yeah, you go, right, you use them to find an average degree. Yeah, is that?
Well, I guess I'm like, so in the past we were going the other direction, so we wanted to find those exponents and those coefficients, right? So are we going backwards now, because we know the exponents?
Oh, I see what you mean. Yeah, so we know them for the underlying, or we specify them, and we want to find we'd like to find the degree distribution for the induced networks, right? So
we normally start from that.
Yeah, we have to. There's a step involved here in between because we've got stories and tropes, but we really want to know this. I mean, we don't have, but we're interested in the stories connections with each other. Boards being connected to each other, very useful thing to know about, and the directors being connected to each other. So we want to get that out, and for random ones you can do all this kind of nice math. But in reality, you've got some actual bipartite thing. You look at the structure and so on. You'll want to see as a first step how far it departs from pure randomness, and then sort of move along and say, okay, there's some mechanism here that's driving something that's making the people clump together or whatever it is, for good or bad.
Okay. So one other question I have is
Yeah.
more general. I'm not really sure exactly when it's appropriate to use generating functions. What
Yeah.
kinds of things in the problem that we're looking for that would tell us oh, we should use generating functions here.
I think, and we won't go on past this lecture with them, but they've been a pretty interesting addition to this development of this field, right? Because they initially allowed some things to be solved, right? We just didn't know things like what's the size of the giant component. We just did, right? These were the first ways to get into it. And I'm sort of keeping it in here because it's kind of a beautiful piece. But I think, I think there's still good theoretical stuff that people might develop with it. But I also want to show how we can really do all of the important things with physical arguments. And that's next. That's like next stuff. So we'll back off this. You probably won't need it. But generating functions, that said, generating functions are, for networks. I mean, you should.
Is it just like when a problem's super hard, try generating functions?
Okay, yeah. Well, I mean, you can definitely get somewhere. The problem is like as you get to more complicated stuff, the sort of things that you'll see is, someone will use generating function, but then they'll basically just do something with Mathematica. And you get a page of like scrambled numbers, and it's sort of like, what are we doing at this point? I think the really important thing here is random bipartite affiliation structures, right? Which we can get at in different ways. I think if you want to find out things like the actual distribution of component sizes, right? There's a giant component which takes up 0.7, and then the next biggest one is, there's a whole bunch of them that are of size 13. If you want to get those things, generating functions are a really beautiful way to do that, and you will ultimately have to use something like Mathematica. You'll set it all up if you need those things. So if you need those kinds of details, it's a pretty good way to do it. It's a pretty good way to do it.